So I'm going to do a short stream to explain what I did. Then I'm going to stop and probably come back today again to continue to follow the steps that I have there. Next thing that I'm going to do is just study the loading scene, save scene, saving scene, and new scene functionality. And then start working on the headless thing so I can build everything from, which I still have a lot of questions, so I'm not really sure how I'm going to do it. But yeah, I want to clarify how to save the scene, basically how they write to the files, and then try to create a simple scene just from the code. But I did manage to create the global signals, at least so far. From now, it seems to be working. So I think I'm gonna leave it like this, and then I'm going to, if in case I need in the future, then I'm gonna think about it again. But I think for now it's probably better to just leave it the way that it is now, and then continue with the other stuff, then come back maybe later. The main thing that the signals don't have is just integration with GDScript. So yeah, it only works for from C++ on the source code, which is something that I'm not really sure how I'm gonna do it. So I was getting some errors. I'm not really sure at what moment I stopped last time that I streamed. But basically, last time when I stopped, I tested it out. So I'm going to show here. So this is basically the simple application that I built, and I created a custom button class on the modules and a custom graph class, which is a component that I'm going to use. And I explained how this works on some of the streams that I did before. And I created this. So basically the button is the thing that shows up on the left, and the mesh instance 3D is child of the graph. So the button and the graph are siblings, and the mesh instance 3D is a child of the graph. So when you click here, it changes the position. So the way that I did this, which I might change as well, but I created this global class here, the singleton class, global signal, because initially I was doing on the engine class, but I think that there are two different versions of the engines in the way that they did it. One is for integrating with the script instance, and the other one is the one for the configurations. And that was the problem that I was having, because I implemented these things, and then when I tried to test, it was working, but then it was showing a bunch of error messages complaining that the object doesn't exist, which was something about the registration of the GD class that I'm going to show there. But basically the way that the thing works here is pretty much the same way that the normal signals work, but instead of checking to see if the signal exists on the inside of the object class, which limits the scope of the signal to the object, to the instance of the object class that connected to the signal in the first place, it allows you to connect on a hash, which is a member variable of this class here. So it's this class here. And the way that I'm thinking about doing this, I think I'm going to leave it like this, but I'm not really sure. Depends on what happens. But basically, the way that I have here is I subscribe the signals based on a scope, which is a string name. The reason why I chose a string instead of enum is because strings allow for more flexibility on the scope. And if you use an enum, it would be probably faster, but then you would have to create a new value of the enum each time you want to create a new thing. So it could be better to do that way if you want to limit signals for different scenes, for example. But I think that this way it doesn't matter that much. And then I have the other hash map, which is the signal name and a list of callables. So every time that you connect the signal, you're subscribing a callable. A callable is the data structure that they use on normal signals to hold the information of the function that is going to be called. So it basically stores the callback function information. So the instance of the class that the function is from, the arguments of the function, and all the necessary stuff you need to figure out where the function is, the moment it's called, and to call the function. And basically what the callable is. The list is the linked list. So every time I connect, I'm just getting the scope, which allows me to if I always connect based on the same scope, it allows me to encapsulate based on the abstraction only specific nodes that would be like, it doesn't even necessarily need to be a subtree from the main tree. It could be specific nodes that are on different scenes, for example. And then as long as all of them have the same scope, it allows you to have flexibility on how you wanna keep track of the context. It's very similar to context in React. So as far as the way that I'm imagining now, maybe I'll have to change later, but yeah. And then inside of this scope, then you have the signal name, and this part's pretty much the same. It's different than the way that Godot does it, because Godot forces you to, the normal signals, they force you to subscribe to the signal first, and I'm not doing that, so it might be something that I have to think about. But basically, you put the signal name, and then every time you connect, it appends a callable to the list here. So when someone emits the signal, all the callables are gonna run. And this is another thing that I can change eventually, which is to use a queue instead of a list, because then the queue allows you to encode priority. So, but then it gets a lot more complex. So that's the reason why I decided to do it with a list now. And the reason why I think on Godot they did it like this, so it's easier. So basically, the reason why I have two functions here is because this one is going to be a templated function, it's a variadic template, and the reason why is because of the number of arguments. The number of arguments that you emit on the signal can be arbitrary. So this one wraps the other one, which is the main one that is going to do the call, and just passes the size of the arguments, the count, and transforms the arguments into this other data structure here, and then passes this one to the other function, because the other one is not it's not a templated function. So yeah, and basically just copy it and just change the scope from the emit. I'm going to show the connect first, and then I show the other ones. And the bind the methods here, I didn't bind the methods to the class DB. So whenever you create a class on Godot, you have to use class DB to register the class, because that's how Godot is going to be aware of how many classes exist on the project and how the editor is going to communicate with the C++ code. But the reason why I didn't register the methods here is because on the object class, which is the class that declares the signal, they also don't subscribe the emit signal functions. They only subscribe one of them, but it's not the one that I wanted to use. And I went basically based on the step over that I did to figure out which one is actually the one being used. And the other one I think is just on specific cases that I haven't seen. So yeah, the only one that they subscribe is this one, and they don't subscribe the other one, so I decided to not do it. Basically, the connect is very simple. It just checks to see if there is a scope on the hash. If there isn't, this part is the one that I was getting an error, I think, last time. So instead of making like this, because it's a nested data structure, the hash map doesn't allow you to just add like this if you're adding another hash map, because I forgot the name of the overloads. It overloads the equal operator. So based on the overload functionality, it can't compare two different hashes. So I have to use this insert function instead. So here I'm just inserting so this is the first time that you connect with a scope. If the scope doesn't exist, it just inserts the scope and then makes it equal to the hash map with the string name and the list of callables. So this is just initializing the hash map. Then if the signal for the scope doesn't exist, I just create here and then add, and then basically after I just push the callable that was passed here. So I'm doing this on the graph, which is the custom thing that I created. So this is basically modules. The way that it works is that you have to follow the documentation there, and there are two different files here that you need to have. And you basically declare these functions. The name in the middle is the name of the module you have, which is the name of the folder you put here. What Godot is going to do is just going to go over all the folders that exist as a child of modules, and then you're going to generate a file based on the build system that is going to contain all the functions that are necessary to build each module, which I believe is going to call these functions here. Yeah, it does definitely calls these functions. So here is where you register the classes you create, and once you register the classes you create, you're going to be able to access them from the editor. because what this is doing is just registering them on the class DB, which is the class that the editor uses to check what classes are available for the visualization. And then here on the levels, it determines when because there are several different times that this function is going to be called. I think it's initialize modules or something like this, the name of the function. Yeah, so it's basically uninitialize modules and initialize modules. And it calls this function here as several different steps of the setup process. So basically each one, and I wrote down, I believe there, like their chronological, or not chronological order, but the order of dependencies. So as far as I know, the level core is the like primary one. So it's basically this sequence here. So first is core, then servers, then sing, then editor. And the reason why I think you have these options here is because you can have different options to compile the engine without compiling the editor, for example, or like different levels of compilations. So you need to specify the level here based on what you think the module you're building is gonna need. So here I did the sing. I think most of them are gonna be on the sing level, and this is just calling the register class on the class DB. So you register the classes you put here, and the classes are basically the header and C++ files you put here. So one of the classes that I built was this graph here. And what I'm thinking about doing is just running barn sets on a graph data structure. So on this class, this function here basically. So on the constructor of the class, I use the global signal class there that I created. And then I call that function, which is global signal, pass the scope, the name of the signal. And then I just use the same macro that they use on normal signals to subscribe so basically what this is going to do is going to create a callable class that is going to hold the information of the instance, which is this, with the function that is going to be called when you push there onto the linked list. So this is going to make it so that every time that you emit the move right with the graph scope signal, it's going to call this function at some point because it's going to be inside of the list. And basically, based on the way that I did there, I think it's just like a normal vector. It's going to call whatever you put first, calls first. So yeah, just basically running this and then pushing there. And then I have this other function. So this other function here is the one that I subscribed there. So obviously there could be mistakes with this because I only tested for the simple case and I'm not enforcing the order of things. So one obvious mistake that could happen is that you emit the signal before you connect. And since there isn't any way to enforce this for now, then it might be a problem. But I think for my case, it's probably not. So maybe I'll change this in the future, but yeah. So basically what this function does, I think this is correct, yeah. So this function receives, I'm going to explain the button later, but basically receives a new position. For now, what I'm thinking about doing later is just making this a templated function because I'm going to need several different arguments here. And then based on the templated function, I'm just going to copy the functionality of the emit signal as well to loop over the arbitrary amount of arguments that it has here and figure out which ones were passed to basically update the physics simulation based on whatever ones were passed. But basically, this is a function from Godot, I think it's from the node, that allows you to pass a pattern here to find the children of the current node. So here I'm getting all the children that are mesh instance 3D, which in my case will be nodes probably. And then I'm using this cast to, which is the object function, to change the type from node to the mesh instance 3D. Because that way I can call the translate function, which translates into this vector here. And that's what creates the new position there. So basically I'm receiving this from the signal, and then I'm changing the position like this. But later on I'm going to change the physics simulation values. And then the barn set solver is going to be based on the member variables of this class. So when this function gets called, it's going to update the member variables, which is going to change the physics as far as I can think about right now. And then the other one that I did was a custom button there, which is basically just inheriting from button, which is a class that they create So apparently it's on the scene, but the engine uses this a lot. And this is basically going to be a control node at some point, because everything in Godot that shows up on the GUI is a control node. And the control node has a bunch of functions that are going to be called whenever you interact with GUI elements through the input cycle there. And you can override these functions based on the classes that derived from the control class. But basically, the way that it works is that it just emits signals based on whatever happened. And usually the event that is going to happen is this pressed event. So usually the pattern you do, and this part I have to study a lot more, and that's probably what I'm going to do after this string. But basically, yeah, from the patterns of the editor that I've seen, it's always like this. They create a button inside of some class that is going to work as a, is going to work to manage the data on a GUI doc. So inside of the class, they create member variables that are the buttons and whatever you want to happen. And then on the constructor of the class, they connect that class, which is the button class, to this pressed event. And then here you can determine whatever function is going to run once the button is pressed. So usually what they do, the patterns that I've seen are for the pop-ups. So usually what happens is you press the button, then inside of this function, there is some other event that is emitted. And then based on that event, they change the data from the buttons that are going to be displayed on the pop-up. And they set other stuff that is going to run once you submit the final thing. So for example, on the add child there, you would create, the first thing that runs is this stuff here that opens this other class that has the data structure that is going to determine everything that happens here. Then they change the state of the button based on what happened here on the event that was emitted the first time. So this is a reusable button on the main class. And then they set up another event that is going to happen once you click on create here. And that event is going to be the one that determines what happens. So it's basically the similar logic that I'm using here, but obviously in a way more simple way. So this one doesn't receive any arguments because I think the pass, unless you bind here, you can call bind on this macro, and then you can put whatever arguments you want to run. Or you can just change the button class, I think, and then emit a different signal, because this signal here is emitted, if I remember correctly, on some of these classes here. It has to be. So I think it's probably on the control, because the control node is the one that interacts with the viewport, and the viewport is the one that is going to manage the flow of inputs. So you have the display server class. The display server class creates a window. Display server is a class from Godot that is a base abstract class that, depending on which operating system you're using, you're just going to inherit from the class. So in the case of Windows, it's going to be display server Windows. The display server Windows is going to create the window using Windows API functions. Then the Windows API functions are going to pull the events. Then from that pulling, Godot is going to translate that information to an input class, I think, which uses input map. Then from the input map, there's going to be another function that has control flow to check what kind of event it is. And then based on what event it is going to call some functions from this control nodes classes that are going to, which is the main one, I think, is GUI inputs, which are going to call the function from the class. So every time that you're creating a new class like button, it's going to inherit from control node, and then you can choose to override the GUI inputs function to run your own functionality, or you can just use the normal one, which is going to emit standard events, I think, and one of them is the press. So, and I think that by default, the press is going to emit the event without passing any arguments. So either you change the emit on the function here, or you, so it's probably on the derived, or you put the functions that are not going to receive any arguments, and then you can do the way that I'm doing there, where you make it based on the member variables. So here it's going to call. So this is a standard signal from Godot. So when the button is pressed, call these functions and calls this function. And this one uses the global signal class that I created to emit the event, which is checking on the hash there to see if the scope exists and if the signal exists. And here, whatever you pass later is going to be whatever data you want to pass to the function that is to the functions that are going to be called. So in that case, I'm passing this this value here, which is the member variable of the custom button, to this one, which is going to check to see if there is a signal. And this is basically copying from the way Godot works. If there isn't the scope or the signal, just going to return unavailable. So basically not do anything. And maybe throw this error message here, but I don't remember really well. But if there is, then it loops over the callbacks that you have on the list there. So accesses the nested hash map from scope, then signal. That this returns the list of callbacks, and then iterates over the list, which each one is going to be a callable. Checks to see if it's valid, which is the same thing that Godot does, and then it calls here. And this is going to call, this is a function from the callback that is pretty much the same. It is the same from the normal signals. It just calls the method that the callback subscribed when you sign up. So in this case, would this call, this call here would call this function here. And then it would pass the arguments that were passed here. So it's basically calling this function with this argument. And this allows me to transfer the data from this button here to the whatever function I want to call. And then obviously, if I'm going to change the information that from the physics inputs, all I have to do is just create another class which is going to contain this button here as a member variable. And then on the other class, there's going to be the whole state of whatever I want on the GUI. And then I can transfer the information of whatever I want to the functions. And I think it's probably better usually to do this whatever function is going to be called here to make it as a templated variadic templated function. So that way you have more flexibility on what kind of arguments you want to receive. And then you can put this, you can loop over the arguments and then put a switch statement and then call some SCD functions to cast the type of the arguments to figure out the types, which is basically what they do on the emit signal, one of the functions. And then based on that, you can do whatever logic you want. Hey man, what's up? Nice. I think VS Code is better. It's easier. So yeah, basically that's pretty much it. The stuff about the pressed event, I didn't spend too much time, but I'm pretty sure that the GUI input thing is 100% correct. I just don't remember exactly how it works because I think it depends on the situation as well. But I think for all the GUI elements, you're going to have the GUI input function that is basically from control node, which is a virtual function. And that's the function that the Godot is going to check when it's looping. So Godot processes events by calling Windows functions. In the example I was seeing, then it updates the other class and then loops over the events. And it does some casting thing there with references to check what kind of event it is. And then based on what kind of event it is, it's going to call some other functions from the viewport. And eventually it's going to call a push event or something like that function from the viewport. And that function is going to create a control node there. And then it's just going to call based on the control node, which is the base type. But if they think that where the event happens is not a control node, it's a derived class, it's just going to call the function from the derived class, which is usually what happens with C++. It makes more sense to declare the type as the base type because then obviously allows you to have variation on what kind of thing is going to be called. Because then you don't know based on what people build what's going to be the derived class, but you know the base class. So you just put the type on the generic function as the base class, and then that runs the GUI input function for that class. So you can choose to override what's going to happen. And if you don't, I think it doesn't happen anything like it shows here. Just does nothing. But if you overrides, then you can put whatever functionality you want. And usually what's going to happen on the button class from the editor is that it's going to emit another event, which is the pressed event. And then it allows you to put whatever functionality you want to run after the pressed. But I have to study more. So the main thing that it was wrong. The reason why I was having a problem is because initially I tried to do this on the engine class, but then I realized that the engine class is kind of annoying, which is another thing that I might try to change, which is basically that there's two different versions of the engine class, and the reason why they did like this, probably because of historical reasons, I'm not 100% sure. But there is this version here, and there's another version, which is the core bind. And the core bind is the actual one that gets the registers on class DB. So this is the main one. And this one is going to call the engine functions from the other one. So it is kind of confusing like that, but which I might try to change eventually, but it might be very annoying, and they probably have reasons for this. So yeah, so basically you have this one, and this one, as far as I understand, is the main one. And this is the thing that I'm not really sure, because I was thinking about changing, but now that I know a little bit more how it works, I'm not really sure if it is supposed to be like this, because on this core bind here, there is a bunch of different other classes. And these, as far as I understand, they're basically the main singletons that the whole project is going to use. So they create everything on this core bind stuff here, and then they register all these classes on a core register type function. And that's the part that I wasn't aware. And I still don't understand very well how it works, but that's basically the pattern. And then on that file, they're going to register the other files that the other classes that derived from the singleton. So you can imagine that the engine class here that is declared here is the main one, and then the other one is instantiated based on this one. So the one that is subscribed on class DB is actually this one, which is the core bind, and the other one is just initialized on the other part there, which is this thing here. So the way that I was trying to do before is just initialize here, because what I thought would happen is that this macro here is also very used all the time. It's basically a macro based on the way that they did things. They use a memory pool, and this macro initializes everything on that memory pool. So this allows them to allocate memory instead of allocating. So if you use malloc or calloc on C++, it's just going to allocate memory randomly. So when they initialize like this, because they overrided the new operator, it allows them to put the memory on this based on this pattern here on the memory pool that they created there, which is based on this this other class here. So this class has a global variable, and that variable is going to be the thing that decides where the memory is allocated. And this operator here is just telling C++ to put the memory on this class here instead of using the normal functionality, because they override the new operator, as far as I remember. But right now, yeah, it's basically this function here, and this malloc is from another library, is a kernel library. But yeah, so it's basically here, I think. It's either one of these variables here, where I think it's probably, there's not a lot counts. So I think it's max usage. So max usage is the place where they store everything. And the reason why they do like this is so that you have a continuous amount of memory, as far as I understand, to allocate everything. And then basically, the way that this works is that you have this function here, and this function is called after this stuff happens, which is the new operator runs, allocates memory to the pool. And then if the class that is being initialized overrides this function here, which is post initializer, is going to call that function from that class. Most classes don't do that, so this function doesn't do anything. But on the object class, this it does have a function called like this, which the main purpose, so object class is going to, when you initialize the object class, is going to call that function. And the main purpose of this is to register the class on the class DB. But this is the part that was confusing me. It's still confusing a little bit, because if you put breakpoints here, it seems that the class that is going to be registered is not the object class, it's the derived class from the object. And it's basically just registering the class on class DB. So here it does for the object, so maybe it's the object. But the thing that is confusing is that, so because of this, and I remember this, I thought that it wouldn't be a problem to just initialize the class here. Yeah, because I forgot that there's two different instances of the engine. But then it seems like when you do like this, it still works there, but you're gonna get a bunch of errors on the editor because the editor can figure out that the singleton has the object class. So it throws some weird errors that I still don't understand very well. And the correct way to do it is the other file that they use, which is this register core types. And here is the place where they're gonna register all the singletons and the stuff related to the singletons for the whole project. And this one uses this macros here, which register the class directly on ClassDB. So this is the part that I'm not 100% sure, but I think that there is a difference when you're using a singleton for the project, where you have to register the singleton directly instead of just calling memnew. And I'm not really sure if the purpose of memnew is to register the class. So basically what I did was just change this, and now it seems that it is working without showing any errors there. So just put the macro here. This macro is going to call the register class, which is going to put that on the ClassDB. If the class doesn't exist on ClassDB, it's going to throw some errors at some points because it tries to find the class on ClassDB. It doesn't have it. So it's going to say that it doesn't have some stuff. And also there's a part. So here initialize and this engine that initialized here is the engine from the core bind, which is the main one that actually subscribes the methods and everything else. And the other one is just this one just wraps the other one. So it calls functionality from the other one. And this is the part that I think that it can be merged. So I might try to do this at some point, but I'm not really sure if it's gonna mess it up a bunch of other stuff. But I don't see why to have two classes yet, because all the functionality from the other one could be integrated in this one, and then it would be less confusing, in my opinion. But maybe because of the way that they do things here, it might be better to do things like this. Which got me thinking as well, if it isn't better to just put whatever functionality I put inside of the class, this class here, as part of the engine class or some other class again, because the way that I'm doing here, I'm creating another singleton, and it doesn't seem like this class is going to be too complex, but maybe it depends on the way that it's going to evolve. So I think for now I'm going to leave it like this, but it might be possible that it's better to just refactor this. So maybe if I change the engine, this should be only one class, then I might try to just revert these changes and put the functionality inside of the engine class instead, or some other class. So basically that's what it's doing here. This is registering everything, and then the other one is also so this register core types is going to be called on the main setup function at some point. And it's going to register all the singletons here, and then it calls the other one, which is register singletons as well. So this one allocates memory for the classes, and you put the class inside of the macro, which I think is one of these, which registers them on ClassDB, and then you have to make the engine aware of them. So this is the reason why the engine class has that singleton data structure. So it's like the engine keeps track of. I think what this does is just creates a pointer on the engine for all the singletons of the whole project. So if you create a singleton on the project, you have to call this function for the engine to make the engine aware. So I put my here. And that's pretty much the main things that you have to do, I think. So the engine keeps track of the singletons through this thing here. And that's the reason why it has the singleton member variable instead of the engine. So I think that's pretty much it. Standard GUI classes in Godot are a bit lacking, in my opinion. Code bind is to expose the system to the script API. Yeah, I understand that, but I'm not really sure if it's necessary to create two of them. I think it would be better to just merge the two again and just use the core bind one. I think it makes it a lot easier to understand. So it's kind of redundant. But I'm sure they have reasons for this, and maybe I'm not aware. And this is part of my hesitation to try to change, because I understand that, like, maybe when they were developing, there were some problems, and then they ended up doing things like this because they had to solve this stuff. So, like, I'm not saying that it is necessarily the case that is redundant. It's just from my perspective now, it seems to be. So, I think it might be worth trying to change, but not really sure. The modules I am doing just to create new functionality, because my main goal is to create a kind of like a CLI. So basically be able to create games or create applications straight from code instead of having to use the editor. But at the same time, use the editor if I want to. So I want the best of both worlds because I know that there's things that are going to be a lot easier to build from code and other stuff is going to be a lot easier to build from the editor. And also I don't like GDScript very much or C#, so I prefer to do everything on C++ or one language only, or use Python for scripting if I can. And yeah, initially I was thinking about doing everything on the same thing, but then I realized it doesn't make a lot of sense because I didn't understand how scripting works from C++. But now I understand that you can implement scripting functionality by creating other classes as modules and then changing the behavior of whatever class you want by inheriting from the class. And the other option is the GD extension. And I think that the modules follow more the inheritance approach and GD extension follows more composition. But I think that it's just easy. It's just easier to do new modules and then use these classes that I create on the other stuff that I'm doing to build the project from code, which is the next part that I'm gonna try to do now. I made quite a lot of systems that I really need to share. Things like user options, class. Oh, that would be amazing, man. Things like user options class, a hooks project settings to initialize things at the right time. Class like mutex, it is not naturally exposed to the API as deriving from object is quite expensive. I'll be honest, class like engine, you're right, don't make much sense with Carbind. They're a function of engine in Carbind. Yeah, that's what I'm saying. So there's 5 different functions that don't call the other engine class. 4 of them are for scripts, and the other ones should get the main loop. So like I don't see the point because it makes it a lot more confusing for someone that's trying to understand how it works, like why everything is the way that. But obviously they probably have a reason for this, obviously, and like I imagine that was probably like from the perspective of the person creating for the first time, and because it wasn't only one person, is a lot harder to think about everything because you're developing and then you're thinking about all this other stuff. So maybe it might be one of those things where it's much easier, like from someone that has an external perspective to see. But it might be the case also that I'm wrong and there's a reason and for something that I don't understand. So, oh, you did this as well? Nice. The next thing that I'm gonna try to do is this thing here. So I create a new folder on the editor called headless, and then I change the options there for the commands. So when you execute the engine passing headless, instead of just there was already a headless functionality, but I basically just added to run the function that I have here, and then stop everything. And then here I'm gonna put so the next thing that I'm trying to do, and then I'm gonna do now, is just study the functionality to save scenes, because I want to call functions here, then build all the data structure, all the nodes that I'm gonna create from modules, then build the whole scene from the code here, and then save to the file. Then open on the editor and see if it worked. But the hardest part is to think about how to synchronize the editor with the code that I have here, because let's say I develop a little bit from the code and then I develop some more from the editor. And how do I make sure that the code part doesn't override the stuff that I did on the editor? I'm still not 100% sure how to do this. Yeah, I already spent a bunch of time studying the editor and with the debugger. I'm going to stop here because I'm going to stop streaming because like this is just to explain the other stuff that I did for the global signals. But I'm gonna start streaming right away after this, and I'm going to step over the code here with the debugger and try to understand more the saving functionality. So what happens when you click sing and then save sing, and also to load the scene, stuff like that. Which basically is just writing to the files, but I want to understand how to do this directly from code. So I'm gonna stop here, be right back. See you then.